All right, so in this unit, we're going to be talking about two types of what we call special right triangles. And yes, this is not a right triangle, but your triangle that we're going to talk about will always have a right angle. Now, the first type of right triangle that we're going to be talking about today is a triangle where these two angles are the same. So we've got our right triangle, or a right angle, sorry, and then we've got two other angles that are the exact same measure. They are both 45 degrees. So we call it a 45, 45, 90 right triangle. Now, one thing that we know about triangles that's you're getting even crucial for you to know this unit. We'll get into it even more with our next unit. But our angles and the sides across from them, there's a huge correlation there. So if these two angles, we actually talked about this earlier, if these two angles are congruent, our base angles theorem says that that means that the sides across from them are going to be the same length. Right there. So this angle, if we just call this x right here and call this x, they're going to be the same. We know that. We can actually use our Pythagorean theorem to find out our c. So let's just go ahead and do that really quickly. Whoops, I want red. So we'll call that a, b, and c right here. So if we're going to do that, then we could say a, or x squared, plus b, or another x squared, is equal to c squared. Now, again, we're just trying to solve for c. We know your answer is going to have an x in it because we didn't have a value. But let's just go ahead and solve. If I have one of these x squareds and add them to another one, I'm now going to have, these are like terms. I can add them together. I've got 2x squareds. That is equal to c squared. All right, and then to find the c, the value of c, I'm just going to take the square root of both sides there. So the square root of c squared is just c. And then notice you can actually break this up into two radicals right there. So I do know the square root of x squared is just plain x, and we don't know the square root of 2, so that's going to stay under the square root. So if these two sides right here are some number, this third side, our hypotenuse, is always going to be that same number multiplied to the square root of 2. Okay, so this is just how it is. So your legs are both x's and your hypotenuse is an x squared root of 2. That's what they want you to write right there. All right, now when I do problems with this, so our special right triangles, basically they only need to tell you one side of the triangle and you could find the other two missing sides. And it only works for two kinds of triangles, but this one is one of them, a 45, 45, 90 triangle. So what I would do right here is I would kind of ignore the x's and y's for just a minute. We'll plug those back in. Well, I don't want to turn it into an x. We'll plug them back in just a minute. Okay, so basically let's just cross it all out. Okay, we're just trying to find those two sides. I just don't want you to get the x mixed up with the x right here. Some people use m's and n's and all kinds of different letters, but we're just going to cross out those. They just want us to find what x is and what y is. So when I do this problem, I'm going to label my three sides of a triangle using these letters or these values, x, x, and x squared to 2. Notice the x squared to 2, that's always going to be your hypotenuse. It's across from your right angle. So if I were to do that in this one, this side here would be my x squared to 2. The sides opposite the 45-degree angles are going to be x's. So across from 45, there's an x. Across from 45, there's an x. All right, and then basically they're going to always give you one side. So notice that's the side that they gave me. So they actually told me what my x is. X is 8 right there. So I can just plug that back in. This x is 8 right here. And this, when I plug in 8 for my x, that side is just going to go to 8 squared to 2. All right, so now if I took my eraser and tried to figure out what they're wanting, they could say x is 8, and we could say that y here is this 8 squared root of 2. All right, not too bad, right? Let's try one more example, and then we will go on to another special right triangle. So here's another nice, lovely 45, 45, 90 triangle. So again, I'm going to just kind of cross these letters out for just a minute, and I'm going to relabel my triangle across from my right angle. So across from your right angle, there goes your x squared root of 2. And then across from my 45-degree angles, those are x's. So now this time, they told me that what x squared roots of 2 is. So I'm just going to write this over here. 19 is equal to x times the square root of 2. So I am trying to solve for x, so I can just plug it in right here to my x's. So this x right here is just multiplied to that square root of 2. So we're going to undo multiplication. We're going to actually divide both of these sides by the square root of 2. So x here is just equal to 19 divided by the square root of 2. Now, if you've got a fancy calculator, that will simplify for you. If you try and do this, it will write it in a nice form. But if not, we're going to have to do a little bit of work here, because if you'll remember 6 months ago, a while ago, when we did our radicals unit, we told you it was a no-no to leave a square root in the denominator of a fraction, in the bottom of a fraction. So there's an easy way to do it. Basically, whatever that radical is, you're going to multiply both the top and the bottom by that radical. So square root of 2 divided by square root of 2, that's really just 1. Anything divided by itself is 1. So I'm just timesing this nice little fraction by 1. Okay, but what happens right here, remember when you multiply a number outside a radical by inside, you're just going to have a number outside and a number inside. You can only multiply outside by outside and inside by inside. So that'll just stay like that. Now these are both under the radical. They're both under a radical, so we can smash them together and just multiply them together under a radical. So the square root of 2 times the square root of 2 is going to be the square root of 4, which is fantastic. And this kind of is what we wanted to happen, because the square root of 4 is just a rational number. It's just 2. So that just turns into a 2 on the top. It's okay to have the square root on the top. That is your x right there. So these two sides are both going to be 19 square roots of 2 over 2 and 19 square roots of 2 over 2. And then if you wanted to see what letter, they're both the same. So you could say x and y both equal that 19 square roots of 2 over 2. And that's our 45, 45, 90 triangles.